Okay. And now you'll notice that already we don't have any newing up of service level classes in here. We do new up these, again, these DTOs that represent the state of an advertisement. But apart from that, everything else that has behavior is wired up using dependency injection. And note that we now have a dependency graph here. So our controller is going to be requesting an order service, and its constructor declares its dependencies here. So how do we make sure that it gets them when we are making an order service or when we're using an order service up here at the higher level in our controller? Well, the DI framework is going to resolve the whole dependency graph for us. And so it's going to look through the dependency graph and see that when an order service is needed, it also needs to ensure that a deal service and a Chamber of Commerce API are wired up as well. So that's kind of nice. But we still have this issue where we have this order service constructor that's taking in some order state here. And what I want to do is to essentially move the order itself to the call where we're actually processing the order instead of when we're trying to create the whole service itself. So what I'm simply going to do is change the signature of process order here to take an order. This is going to break the interface. That's okay. And then I'm going to move the things that we set on that order to the top of this method. And now I'm going to remove this constructor altogether. Okay, so now process order itself is expecting an order, so let's update our interface. And the other method that we have here is getting an order, which is returning this order instance, or the value on the instance on the order service instance. And we don't really need that either. So what I'm going to do is remove this. And now we're not tracking any value of the order on the instance of order service, and it becomes much more functional. So we'll take a look at why that's great in a moment. So we'll remove that from the interface. Now order service just processes an order. And anywhere that we have an order here, it's no longer a value on the instance, but it's the value that was passed into effectively this method. So we'll come down here. I could search and replace all, but just so that hopefully we can stay together here, I'll just change it all manually. Okay, so now we'll go back up into our controller. This is obviously no longer a valid constructor, and that's good because we don't want to new up an order service in here. Instead, what we want to do is to use our order service that's wired up using dependency injection. So we'll do this, and we'll pass the method order. And now before we were saying completed order is equal to order service.getOrder. That no longer exists, and that's what we're passing to our view. So process order instead should actually return that order after it's been mutated. So let's have it do that. So we come back up here. So this takes in an order, mutates it, all within the scope of this function. The service instance itself isn't tracking that. So at the end here, what we're going to simply do is return that order. So order in, order out. The service itself, again, not tracking any state. And here we should probably be checking for null as well, so we can just check for null. And we could return bad request here, or like a status code. It's really more of a server error than a bad request. And we could log our error out here. Or it's really order error processing order. And we need to wire up our logger, so we can do that with iLogger. The type is just the controller, so order controller. We'll create our backing field. and we'll get rid of our unused using. And here maybe like we can log debug, processed order, and we can use a little string interpolation here just to say we process the order ID. Okay, so this is really bare bones. We're not doing any model validation here, request validation. This is just basically a simple example to pull out the order service and request or invoke it via dependency injection into our constructor here via constructor injection. The other thing that I see here is we can actually instead use an object initialization here, and so we'll do it this way. So now we create a new order and just set its properties on it like this, which I think looks a little bit nicer. And now we're using our order service to process that order, and this is looking a lot better. We can now actually test this controller action if we want without relying on our current implementation of our order service, and we can provide a mock instance or any other type of testable here to actually do things like make sure that if what gets returned from this, whatever it is null, or is not null, that we log this particular message and that we return a particular view that we expect, and also otherwise that we return a status code of 500. This is all going to be much more testable now, and now I think it's time to take a look at the order service itself and see if we can clean this up a bit. So there's our interface. Let's go into the implementation. And anytime I see a big if-else block like this, the first thing that comes to mind is, can I instead create an object for each block here that behaves in a certain way? In other words, can I send an object a particular message so that it can handle all of this this business logic that sort of looks really procedural right now? And the answer is yes. In this case, we can definitely do that. So let's take a look at what that might look like. So I can see that we're keying off this order.district to lower is equal to Cambridge, Middleton, County, or Downtown, and then we're essentially doing some variation of the same thing. And so what I'm thinking it here is that this is basically, each block is making an advertisement, setting some properties on it here. Maybe there's some other business logic involved, but essentially it's going to set that advertisement on the order, and it's also going to send it off to a printer. And then it's going to mutate the status property on it to set it complete. So what I think we have here is essentially a district order processor, maybe. And so we have a different type of district order processor for each district. So what I'm going to do is directly in this class to start with is I'm going to say we have a public class. Let's just start with the simplest possible thing here. We have a Cambridge order processor, and what does it do here? Well, it processes an order itself here. And rather than say process here, let's be a little more specific. Each one of these things, as mentioned, is creating an advertisement and printing it, and then setting the order status to complete. So I think what we'll do here is we're going to say print advert and update order. We can come up with better names here as well. I think names are one of the hardest things, and also one of the things that we should actually be thinking the most about, especially when we're comfortable with some of these other concepts. So we're going to pull out the logic here for this. So we'll have an async task, and let's say that this returns the order. We can see that it's going to need to take in the order. And now we can see that this class actually has a dependency on the Chamber of Commerce API and a method that we don't have on it called print advert. So let's take this one step at a time here. Let's make a constructor for this guy called Cambridge Order Processor. It takes the iChamber of Commerce API as a dependency. We set the backing field for this on our new class. And then we have this print advert, which was currently on our order service itself, but we should have an object that's basically responsible for the printing. And so what we're going to do here is make a class called advert printer. And I don't care that this class is small or that it only does one thing. In fact, that's a good thing, I think. So what we'll do is we'll take this print advert method out. We're going to make this the responsibility of this advert printer class. And we can even just call it print. We're going to extract an interface for the advert printer. And now our Cambridge order processor here as a dependency, we'll declare another dependency here, this iAdvert printer. And we'll create the backing field for it on this class. Okay, so now we can say printer.print. And we'll return the order. Okay, so now we have a Cambridge order processor. We can see what its dependencies are for sure. Okay, so before we sort of get lost here, what we're going to do is we're going to say one step at a time. This will get cleaner as we go. But here, if we have a Cambridge order district, then our order processor, we'll say order processor is a new Cambridge order processor, which for the time being takes our Chamber of Commerce API and our printer, which we need to wire up, and we'll say order processor, print advert, and update order for this. And we await that. So now, again, this is going to change, but if we come up here, if we just take this logically one step at a time, now the dependency for the printer comes up a level for the time being, and so that we can pass it to our Cambridge order printer. Alright, so let's clean this up so we can start to see the structure. I'm going to add a new directory for a namespace here called order processors. We'll add our class for Cambridge order processor. And we'll move our Cambridge order processor directly into that file. Bring in our unused usings. Bring in the imports into our order service. Now we have our advert printer, so I'm going to go ahead and create a new directory called printers. We'll add a class advert printer. We'll bring this class where it belongs into the new advert printer file. Bring in those imports. And now I'm going to pull out the interface iAdvert printer into our interfaces. And bring in the imports. Okay, so if we come back here, we have new namespaces for these. They're not on the order service, obviously. And just a typo here in the class declaration. Okay, so let's see where we stand with our order service now. So we have an order service that declares its dependencies. We've got a constructor that sets those backing fields. And now our first if block here is actually looking a little bit cleaner in that we just create an order processor, and then we await printing the advert and updating the order. Now, we know that it is a bit of a flag here if we're newing up objects, but let's worry about that once we're done sort of ironing out this first pass of cleaning up this bit of logic. So we want to repeat this pattern for Middleton, for County, and for downtown here as well. So what I'm going to do is create those 3 classes. So we'll create Middleton order processor, create our downtown order processor, and what was the other one? County. So we'll create our county order processor. Okay, so if we look at the structure of the Cambridge order processor, we basically just have this print, advert, and update order method. So we're going to use the same in each of our other classes here. Because effectively that's what each of them is doing. They just handle it in their own special way. Okay, so now what we can do is we can go back to our order service. We'll take the county logic here. We'll put this in the county order processor. We'll import our usings. And we can see that the only dependency of the print or the county order processor is printing an advert. So say county order processor advert printer. Create the backing field for that. Printer.print, return order. This particular method doesn't even need to be asynchronous. And while we're in here, I'm also going to use an object initializer for the advert. Definitely some more cleaning up we can do. We'll go back into order service. And now when we have a county, we can say order processor is equal to a new county order processor. Here we just require the printer. And then let's pull out the Middleton. Oops, okay, so there we go. So we can see that this one actually has a few dependencies. First of all, we need a deal service. We need a chamber of commerce, and we need a printer. Okay, so I'll clean up the way the constructor looks here. I like putting the dependencies each on their own line, and then we'll create our backing fields. And sorry, this should be private read-only. Printer.print, return order. And I need to fix this typo there. Okay, we'll use object initialization just to get that a little cleaned up while we're in here. And in fact, if we undo this and move this up here, Now if I move these up here, actually, we can actually initialize more of those properties at once. Okay, so that's the Middleton order processor. We can go back into our order service here, and in the Middleton section, we'll make a Middleton order processor, which takes the deal service, the Chamber of Commerce API, and the printer. Again, not ideal that we're newing up those services here, but we'll see how that gets ironed out in a moment. Here we don't need to await. And finally we have our downtown. So then we go into the downtown order processor. We bring in our imports. Make our constructor. This one looks like it just depends on a printer. And we got to make sure we return that order. Again, this one actually doesn't need to be async either, it looks like. And we'll use object initialization here. Okay, so we're kind of hacking away, and we should now be able to go back to our order service, and we have an order processor here for our downtown order processor. Which just takes the printer, and then we print advert and update order. Okay, so what do we see here now? Well, we no longer have a bunch of if-else statements with their own logic. We're now sending messages to objects which are essentially determining the status of this order and the way it gets mutated. When I see an if-else statement like this that essentially creates different versions, different variations of the same object, I immediately think of a factory. This is the behavior of a factory to do this type of thing. So how can we actually replace what we have here with the behavior of a factory so that when we do create new districts that have their own order processors, we don't actually need to update the code of process order, but rather we can extend some factory to have some new behavior and extend the code base with just these new objects as we need them. We shouldn't have to dig into the process order logic itself when we have new districts. So let's take a look at that.